the Vermont Agency of Natural Resources, and I want to welcome you to today's webinar on stormwater master planning. This is the fourth in a series of 5 on this particular topic, each one focusing on a different approach. Today we're looking at stormwater management for large lots and watersheds. Again, we're joined by Watershed Consulting Associates, and Andres Terizo, principal there, is going to handle the bulk of the presentation. Just a few quick notes. We are recording the webinar, as we always do. We'll post a link in the next few days in our YouTube channel. I'll send that out to everybody that registered. All attendees will be muted throughout the presentation. If you have any questions or technical difficulties, feel free to post them in the question box. So that's within the control panel on the right-hand side of your screen. Any questions that come up, we will ask to the presenters at the end of the webinar. A few people in the past have asked for certificates. It's a pretty easy thing for me to do, so if you need one for professional development hours or anything else, just let me know and I'll get you one after the webinar. And that's all I'm going to say. So Andres, over to you. Thanks.
Thanks everybody. Welcome back to those who've seen some of the previous shows. We'll jump right into this one here. First, just to talk about the the approach for this specific template. This template's really geared towards municipalities with larger urban areas. Also, areas such as town centers, academic campuses, or recreational resorts. And really the key is contiguous areas that are generally under one ownership makes this approach a lot more ideal. And as far as funding this approach through the Vermont DEC ERP, this does meet the requirements for the ERP funding if you follow all the steps of this template. It would also meet the Department of Housing and Community Development as well. It's not exactly well suited towards the VTrans Better Back Roads program because it's not really dealing with back road type road erosion issues. So before I get into the main case study example for this particular template, I wanted to hit on one example which really helps you understand what the framework is for this specific template. So the example that I can present here is Middlebury's Industrial Park. And this is in Middlebury, Vermont, and the industrial park there really fits a pretty typical layout of any industrial park. It's a central road, central infrastructure surrounded by individual lots which have been developed out and are generally being treated with one centralized type system or a few centralized type stormwater management systems. And in this particular scenario, which is very typical for an industrial park, you have a central property owner who upfront builds and maintains stormwater facilities. And these would typically be things, most often retention pond systems. And those systems are designed for the build-out of the industrial park. And they are located on common lands under the control of the main landowner. And really the advantage to this approach is that a lot of the permitting costs and upfront concerns are really can be dealt with by one landowner, and it's a much easier permitting process through the state for stormwater management, operational stormwater permit. And the systems basically the costs could be absorbed by the landowner, by the developer, and then prorated out by most often the impervious surface associated with each lot. So, for example, facility A may have 15–20% of the impervious surface associated with the industrial park, so then they would therefore pay a prorated share of the operation and maintenance of the stormwater facility and all associated permitting based on the impervious surface. And that would be in contrast to a situation where each lot may have its own stormwater permit, and there could be potentially 15 permits for a facility such as this, which makes things quite a bit more complicated and also probably more expensive as well. So that's just to give the general framework of the type of approach that we're going to discuss today. And the main case study in this template is the University of Vermont campus in Burlington. And the campus in Burlington is 75% of the runoff from the campus presently drains to some form of a centralized stormwater facility. If we look down in the southwest campus area, we have a few basins serving that particular area of the campus. These basins are serving runoff from the central developed core campus area. These structures are generally built to the latest standards or being upgraded to the latest standards. So we're looking at things more like this versus something such as this, an older style stormwater management facility. The real advantage to this approach is that the needs of the university can be met easier, meaning the university can really lock in, I guess, storage, treatment within a centralized basin and basically do that work up front before the development has actually occurred. And the university can, by using this approach, the university can better plan for the future growth allocation. And the assessment can be done really to look at the university and say, you know, where is the development going to occur in the future, and what size stormwater management facility might we need to accommodate that growth. And the infrastructure could be put in place ahead of time, permitted ahead of time, and then once that infrastructure is complete, the development can kind of occur on its own schedule, and versus trying to design and permit with each small scale improvement, which is typically a more intensive type process, more complex as well. So in UVM's master plan, they've also included areas of potential purchase and development, and those are, you know, those areas are considered when designing and also improving, upgrading stormwater facilities at the campus. In addition to that, UVM, just to give some perspective, UVM is a non-traditional MS4, and so it is in itself an MS4 entity. It has an MS4 permit through the state. So because of that, UVM is subject to the 6 minimum measures, which we've discussed in previous webcasts associated with the MS4. So those 6 minimum measures are required by UVM as they manage stormwater, and in addition, they're also subject to industrial stormwater permit requirements. Even though that's not necessarily part of the MS4, any industrial facilities are also required to be covered under the multi-sector general permit and create a stormwater pollution prevention plan for those sites. And there are some facilities on the UVM campus that would fall under those industrial sectors, such as the safety facility, the environmental safety facility lab. And to add to the layers of regulation, and UVM is also subject to flow restoration plans. And this was something that I previously discussed in a prior webcast. The flow restoration plans are required in the stormwater impaired watersheds in Vermont. And because UVM drains to stormwater impaired watersheds, Englesby Brook, Potash Brook, Centennial Brook, those discharges are also subject to flow restoration planning. And the goal with the flow restoration planning is to decrease in-stream high flows and also increase stream base flows. So in cases where there is existing stormwater infrastructure, these basins that we're discussing, the basins are now being included in these flow restoration plan models to understand their existing capacity for managing flows, and also potentially how those basins might be modified to optimize control of flows, and potentially also where there could be opportunities for infiltration on the campus as well. In addition to the three watersheds, the three impaired watersheds, UVM also does have lands within Bartlett Brook and Sunderland Brook, so they're also subject to participation in those flow restoration plans as well. So looking at the DEC model outline achievement, which is the framework for the DEC master planning template, this particular approach does meet all of the model outline requirements because, number one, we've defined the problem. There has been an existing data collection by means of plans and trying to understand what would be available in the existing condition for better evaluating the stormwater management on the campus. Collecting new data, such as doing surveys and doing updated modeling studies of those plans. Trying to work the master planning framework into the existing management program at the university, and also summarizing the results of the assessment. So that covers the UVM master planning case study, and I'm now going to show you just some links of interest, and we can circulate these later as well. But right now I'm just going to jump into part 2 of the broadcast, which is going to carry through and hit on another case study in Williston. So for this section of the broadcast, we're going to jump right into the next template in the DEC framework, which is template 3A, and that is the large watershed or regional approach with planned build-out, which I think is the key phrase there, planned build-out and traditional end-of-pipe stormwater management in some cases. So to jump right into this approach is particularly suited for larger urban areas, town centers, or potentially multi-town areas. the funding available for this template, the ERP is available. The Department of Housing, Community Development, Better Back Roads is not, similar to the last template that we just went through. So talking about Williston, I'm going to present a case study on the town-wide watershed improvement plan that was done for Williston. Give a little background on Williston. Its population has increased pretty dramatically for Vermont municipality. From 1960 with a population just over 1,000 to 2010 where our population's almost 9,000. Population doubling since 1990. There's been a lot of commercial residential development which has resulted in significantly more impervious surface. And that has created water quality problems. And so Williston had taken the initiative to better plan for the problems that were starting to be seen with water quality, and engaged to complete a master plan study for that, to really understand what the existing problems, the scope of the existing problems, and then potential solutions for those problems, and then also with the future, potential future problems by doing some model prediction. I'm going to go through that. And so really the first step in that study was reviewing existing data, looking at how, because there were many different watersheds with their own particular issues within the town, how could those specific issues based on the watershed, water quality, position in the watershed, how could that all be evaluated together to understand where the priorities would be in the town for stormwater improvement? Identifying specific problem areas within the town, completing field surveys of those areas, and then basically classifying and then ranking those problem areas for pushing the highest level projects along for design and implementation. So the first step in the process, the whole host of data available in Williston, depending on where specifically you are. For example, there's basin planning data available through the Vermont Agency of Natural Resource. There's also stream geomorphic assessment data, water quality monitoring data, and then certain areas of the town are subject to total maximum daily load development, specifically Allen Brook, subject to flow restoration plans. So just to put a finer point on some of that data, the Winooski River Basin Water Quality Management Plan, chloride assessments have been done, watershed improvement plans, talk of a sediment TMDL with associated project list, hotspot project list, biological in-stream aquatic life data, geomorphic data, Allen Brook restoration projects, TMDLs for biological impairment, stream gauging data, flow restoration plan, water quality monitoring, whole host of data. And this is probably more than what most areas would have because the Allen Brook is stormwater impaired, so it would have a exceptionally large amount of studies have already been done there. What I mean when talk about developing comparison methods between the watersheds, really within the study, the specific characteristics of the sub-watershed areas within the town were looked at. So there was, there are a range of watersheds within the town, and each one really has its own specific challenges related to water quality. And also, just related to the physical characteristics of the watershed. And so it was acknowledged that, potentially depending on where a stormwater hotspot might be located, it may be treated differently as far as, the relative ranking of importance on that particular project. Just for an example, talking about size of the watershed, a particular area that is generating a lot of stormwater flow may not be as critical of importance if it's draining to, say, the Winooski River with a very large drainage area versus a small headwater tributary where excessive flows may be much more damaging to the stream versus a larger watershed where there may be room to absorb excessive stormwater flows. So that's just one example of how to think about a stormwater hotspot. Just because it's a bad stormwater issue, it may not have the same importance depending on where that is located within the greater watershed and within the sub-watersheds within the town. Same thing with impervious area within the watershed. Is it connected? I'm going to get into that in a little bit here. Is it disconnected? Is the watershed already impaired? What is the impairment? What is really the problem? Where is that problem coming from? Is the area that is this hotspot is draining to significant recreational natural resource? Should it have a really high priority for repair based on that? So the investigators first identified problem areas by querying public and talking with the town, completing windshield surveys, and completing problem area ID field survey forms for each one of these hotspot areas. Each site was visited by the consultant and the town staff for evaluation. Those existing sites were ranked, and they were ranked by the relative environmental impact, the frequency of the occurrence, the stability of the problem, really how urgent, is it that problem be fixed? Is that problem impacting existing infrastructure, creating a burden on the infrastructure? How feasible is the solution? Is it something that would be a low-hanging fruit type project that could be easily implemented? And then the impacts beyond water quality, things like a perched culvert where there's a blockage for aquatic organism passage, or somehow part of a larger systematic problem. So for each criteria, scores were assigned from 1 to 10, and a master list was developed where a final ranking of projects was created with the highest important projects scoring the highest number. And those projects would be pushed toward a phase 2 study, which I'll describe in a little bit. Williston's plan, I would say, is innovative because first, it does incorporate a build-out analysis, and I'm going to get into discussing that in a little bit of detail next year, where beyond just the existing problems, the plan included modeling storm events for future conditions to understand how, based on projected growth development within the town, how stormwater flows would change in the future, and how current regulations would impact future flows. And as a part of this study, the investigators parsed out effective impervious cover versus total impervious cover, which is a pretty important, very important concept to understand, I think, with any kind of stormwater management assessment. So just to talk about that in a little bit of depth, the effective impervious area is really the area, the type of impervious area which is really most damaging to water quality. Effective impervious cover area, shown more so on the right, is impervious cover area which is directly plumbed to surface waters, where there are areas where there's a really efficient connection between runoff from impervious surfaces to the stream. So imagining a situation like a large parking lot with catch basins. The water flows directly from the impervious surface with all the pollutants from that impervious surface, all the volume, basically right from the precipitation, translates directly to runoff, conveyed right to the water resource. There's an effective delivery of the pollutants and the volume to the stream. Versus something on the left where the impervious surface is buffered from the water resource by natural or at least pervious areas. In these instances, you have an opportunity for runoff to be mitigated by low slopes, good pervious soils, vegetative areas where the water slows, disperses, infiltrates before it can actually get to the water resource. So not only are you having a lot less water making it to the water resource, but you also have cleaning, you have detention, and that type of scenario is much less damaging to the water resource. So it's not just looking at impervious cover in total. It's really looking at what is connected and what's not connected. And the investigators in this study estimated the effective impervious cover area, which was combined with projected build-out results based on models completed by the town and then also by the consultant for residential and commercial areas in the town to predict overall land use changes. And these land use changes were used to create these stormwater model inputs, which would serve to anticipate where in the town there should be focus for planning and permitting, and what the permitting should look like to manage these additional flows. And the next step in the master planning process for the town, after completing the existing conditions survey, putting forth a list of top projects that should be explored further, was really a phase 2 type project. And the phase 2 type project was really looking at completing the engineering analysis of each one of these problem sites, doing concept plans, doing, in some cases, I would imagine, a final engineering plan, and actually implementing solutions for at least one pilot site with more to follow. So that's really, I think, an ongoing effort right now for the town. And the initial assessment that's been done, the initial master planning assessment that's been done, has laid the foundation for doing this additional work and justifying why certain projects should be pushed forward. The other things that were mentioned in this master plan should be considered, similar to UVM, was also that Williston is an MS4 community, so they're also subject to the same 6 minimum measures. Within Allen Brook Watershed, the flow restoration plan is also applicable. So it says Bartlett, but we're talking Allen Brook here. The associated with the flow restoration planning is the stream flow monitoring. and which is going to be something that's going to be implemented within the next several years. And the purpose of the stream flow monitoring, again, is really to validate and gauge the progress on the flow restoration plan. So as projects are being developed in Allen Brook for retrofit, question of how is the stream adapting, and are the retrofits working as the model, as we expect they should be working within the framework of the model. So looking at the overall model outline achievement again, back to the DEC master planning framework. This approach, this template does meet all of these outline requirements simply because we're following the steps of defining the problem, really doing a exhaustive search and discussion of all the existing data which has been produced, then going out actually collecting new data, not only to evaluate existing problem areas, but then also to take another step and to look at the future problem sites which were predicted based on stormwater modeling. And then looking at and making some conclusions about how the existing stormwater management regulations in the town would be applicable, would be useful for managing existing but then also future flows, and potentially what some improvements could be to the existing regulations in order to better manage these higher flows, specifically which were determined to be in kind of a core area of the town. It was determined that there was a focus area of the town which, based on the zoning and based on the effective impervious cover, based on the modeling work that was done, there would be a specific area of the town that was really going to be subject to much higher flows in the future. And so how could regulations mitigate those higher flows if development, will continue? And then the final summary and recommendation section. So not only looking at the existing problem sites and which ones should be kind of advanced to a phase 2 design and implementation, but also from a regulatory standpoint, I suppose, what could be done to better strengthen town regulations. So here's the web address again for the master planning guidelines. And that concludes the overview of the template 3A.
Great. So if folks have questions, definitely ask them now. I did want to note that we're going to be adding a 6th webinar, if you can believe it. In that one, we're going to talk about the Crosby Brook Restoration Study, which looked at discharges along the Route 5 and Interstate Route 91 corridors in the vicinity of Crosby Brook, which is a 303D impaired waterway down in Brattleboro. So the project included a comprehensive study of the existing public stormwater infrastructure with identification, evaluation, and ranking of potential stormwater treatment practices. So that webinar is going to be on Tuesday, November 25th from 1 to 2:30. And will be presented by Comprehensive Environmental Incorporated. Working on the flyer for that now, and we'll definitely send out some information to folks. So it's going to be a nice addition to the series. The series are looking at the different templates, and this is actually kind of a really detailed case study of a master plan that was created using a variety of different templates. So pretty excited to add that to the list. So I don't see any questions coming in. Oh, there is one. Let's pull that up. Just wrap this up this way. This is a long one. All right, so it looks like there's a couple parts. So Rob Hyams from Charlotte. So going back to last session's scale, common lands, multiple adjoining landowners, How many of these projects have been permitted and funded by the state? And then there's a couple parts of this. How many do you anticipate permitting and funding over the next 5 years? He says, I've seen 3 presentations on the subject. Each one uses Waitsfield as the case study. And then, do you have experience with any models designed specifically for rural landscapes? And there's a couple other parts, but I'll let you deal with that for right now.
So you want to answer the funding question? I'm not sure about that.
Yeah. Yeah, I can answer the funding question. So there's a number of these projects that come to the Ecosystem Restoration Program for funding. Just because a project is identified in a Stormwater Master Plan as a high priority doesn't necessarily mean it will be funded. Generally, those projects rank pretty high based on our criteria, but the money that we're giving out is pretty limited. It's only about $2 million. At this point, MS4 communities are not eligible for that funding, and a lot of the Stormwater Master Plans have been done in MS4 communities. So those projects are kind of off the table, just based on our current criteria. But there have been a number of projects that are funded. I don't have a number on those for you, Rob. But yes, we do actively fund those projects when they come in, as long as they rank high based on our criteria.
And then to the, I think the question was an appropriate model to use for rural road environment. Was that?
Yep.
So for the rural road master planning work that I've done personally, I haven't actually been using any models. We've been using a different, kind of a different approach, which I think we're going to get into a little bit more in the next webcast, the final webcast that we do. But just, you know, the thought off the top of my head is that something like a HydroCAD model might be the most appropriate thing, because I think in the rural road areas, if you're looking at, you know, the damage types of issues that you're really looking at are driven by high stormwater flows coming into the road right away, coming through culverts, through ditches. And so using a tool that's just going to be predicting where the highest flows are could, I think, guide you towards likely problem areas if you're using the model as a tool to just maybe boil down kind of where the highest flow areas would be. I think something like a TR20, TR55 would be a good tool. I wouldn't typically use a model such as WindSlam source loading management model, geared much more towards the urban environment. I don't think it's really going to do. It's not really going to be applicable in that type of environment. So I would think something like just a runoff model would be most useful, kind of in a typical rural road Vermont environment.
And then third question here, so Williston and others like it, is there funding for phase 1 scoping assessment type work? So yep, so the Ecosystem Restoration Program does fund stormwater master planning, and we're definitely pushing communities to do this. We develop these templates as a tool so folks could do that. So we do want to fund those types of projects, have and more than likely will continue to in the future. And I believe that Lake Champlain Basin Program and a couple other funding sources would be good sources for that type of funding as well. Any other questions? Okay, seeing none, we will wrap it up. So thanks again, everyone, for attending today. Thank you, Andres, for the presentation. As a reminder, session's recorded. Send it a link in the next few days. Next webinar, the 5th one, is scheduled for Friday, November 14th. And that one is going to focus on regional multi-town approach with particular attention paid to rural roads. So Bob should probably take a look at that one. That's going to have a rural focus. As always, if you have any questions or feedback, don't hesitate to contact me. Get in touch with me if you need certificates for professional development hours. And that's it. Hope everyone has a great day and a good Halloween. Take care.
Thanks for listening.